You can have. You just need a Sharpie. Okay. There's an electronic one in the back.
Thank you.
All right, we're going to go ahead and pick up on page 47 where we left off on Friday last week. Before we start this, though, I'm going to take a look at the board behind me. You guys can see it. We're going to wrap up this section today. We just have one page left. It's not going to take that long. So we're most likely going to start the next section today as well. But if we start to look later this week, we're going to be having our first partner quiz coming up on Friday. Good morning. Anything for the office today? I think we're good. Thank you. All right, so in preparation for our first partner quiz on Friday, we're going to have kind of a review day where we do some of those free response type questions. Now, we did one of those together the other day, like where they give us some information at the top and then they ask us some multiple questions about that. You guys are going to be working in groups on Thursday with some different of those multiple, or not multiple choice, free response type questions. Now, it's worth noting that whenever we do these free response days, like as kind of review days, in your groups, one person will be responsible for coming up here and showing us your work. I know that can be a little intimidating for us, speaking in front of a group, showing our work, our thought process, and all that. So if you volunteer to be one of those people that come up and show us your work, you can get up to 3 bonus points to put towards this quiz on Friday. Now, I say up to 3 bonus points, so depending on how thorough you are or how accurate you are, you can get less. But let's just make sure we're all good and understanding what's supposed to be going on. Okay, so are there any questions about the week ahead of us? No? Okay. I'll give you more information about the quiz closer to the date. I'll let you know on Thursday who you'll be working with and then kind of what the format's going to look like for the quiz. Okay? All right, so on page 47, we've been talking about kind of graphical characteristics, how we can look for different pieces of information on a graph. We've been looking at domain and range. We've been looking at ordered pairs. On Friday, we were looking at increasing and decreasing, like where the graph's going up, where it's down, where it's constant. We're just going to keep continuing to add to that list. Okay, what are some other things we can look for on a graph? Okay, what are some other properties or characteristics? So on page 47, we're going to take a look at where f of x, meaning the graph or a function, is equal to 0, greater than 0, less than 0. That's the mathematical notation. Okay, that's function notation, but we're going to discuss what does that actually mean. What should we be looking for on that graph in order to satisfy these different notations. So we are already familiar with f of x representing the y variable, and I want you to perhaps use that connection to help you with some of this notation. So for the first one, if f of x equals 0, you can think about this as y equals 0, because f of x and y are the same thing. If f of x equals 0 at a given point, where should we be looking for that point on the graph? What do you think, Alex? Yeah? It's an x-intercept, and the x-axis is where you have a y value of 0. So again, this is the function notation, but we got to think about what does that mean. Okay, what should we be looking for? So we should be looking for points on the x-axis or those x-intercepts. What if we want the function or the graph to be greater than 0, meaning positive? Can we think about where y values are greater than 0? Do we keep going, Alex? Yeah.
It's on the right side of the y-axis.
So that's where x values are greater than 0.
This will be on the bottom, below the x-axis.
Are y values positive below the x-axis? They're negative. Where are y values positive? Go, Pietro? The top half of the graph, meaning above the x-axis. Okay, so if we equal 0, we're on the x-axis. If we are greater than 0, we are above the x-axis. Kind of the last bit here, if we're or less than 0, meaning negative, we must be below the x-axis. Okay, so we're going to add this to our list of graphical characteristics. Where is a graph positive, negative, or 0? Okay, it's all kind of in relation to that x-axis. So we're going to go ahead and try to identify where these different characteristics happen, and we're going to get used to the interval notation a little bit more, like meaning brackets or parentheses. So our first one here, we want to figure out where f of x equals 0. We said those are x-intercepts. Okay, they're specific points. So if we were to kind of show those on the graph, looks like we'd have 3 of them. And we can label those x-intercepts with their values. It looks like we get -3, 0, and 6. The next one's asking us about greater than 0. So where are the y values positive? We said that was above the x-axis. So maybe kind of highlighting or showing that section would be beneficial. All right, so using an interval notation, kind of think about domain and range. We're going to think about where does this interval start? Where does it end? Do we have any numbers in between the beginning and ending points that are kind of tricky, like if we have to skip over them? And we always have to remember the question at hand. So this question's asking us, where is the graph bigger than 0, meaning above the x-axis? So it looks like when we start to highlight this, we start at -3. And let's ask ourselves, are we above the x-axis at that spot? No, we are on it, right? So if the answer is no, this point does not meet this criteria, we would need a parenthesis. Okay, we cannot include that value. As we continue to drag our pencil across, we got to ask ourselves, when do we come to another point that is not above the x-axis? Yeah, 0, right? That's another spot where we are on the x-axis. This question's asking us, where are we strictly above the x-axis? So we'll have to end that first interval at 0. And we'll have to use another parenthesis because it does not answer the question. Okay, it is not above the x-axis. We clearly have more graph to trace, so we'll throw in that u. And we set our pencil left off at the x value of 0, so that's where this next interval will start. And as we continue to drag our pencil across, we're going to ask ourselves, when do we get to another spot where we are not above the x-axis? What do you think? Yeah. 6. Okay, so there's another parenthesis. So at first glance, when you take a look at the initial section that we highlighted, it seems like all of it is above the x-axis. So you might just think -3 to 6, but you got to be careful because it's just asking you where are you completely above the graph. We have to skip over those x-intercepts because we are on the x-axis at those spots. Okay, a little tricky. Let's check out the next one. Where is the graph below the x-axis? Maybe you want to highlight those portions. And we'll start our pencil, beginning to drag. We got to ask ourselves, where do we first start below the x-axis? Looks like we have an x value of -5. Okay. So we got to ask ourselves, is this point where we start below the x-axis? Yes. Okay, so this is when we would need a bracket. That beginning point satisfies the question at hand. It is beneath the x-axis. As we continue to drag, it looks like this first little highlighted section stops at -3 for the x value, and we got to ask ourselves, are we below the x-axis at that spot? No, because we are on the x-axis, so we cannot include that point. We still have another little section to include, so we'll throw in the U. And it looks like that little section goes from 6 to 7 on the x-axis. So we just got to figure out brackets, parentheses, where do they go? So at 6, it looks like we are on the x-axis, not below it. So we cannot include that point. And then at 7, we are beneath the x-axis. So that is a yes to our question. We can include it. Are we starting to get a little bit better with brackets and parentheses the more we go through them? It's all about the question. Okay, does it satisfy the question or interval you are describing? So when we did increasing and decreasing on Friday, we kind of had this nice pattern where we noticed every single interval was parentheses, because at those changing points, those changing directions, you are not just going up or going down. Notice how when we're describing location, like whether we're on the x-axis or above and below, sometimes we can have brackets, sometimes we can have parentheses. It's all about the question at hand. Are you above or are you below? So in terms of kind of being able to identify these intervals, what they should look like, we don't really have a go-to rule like we did for increasing or decreasing. So increasing and decreasing were always parentheses. But if you're asking about above or below, you may have some mixture. Okay, so unfortunately there's no like clear-cut way to remember that. Okay, it's all about the question at hand. So should we use closed intervals or open intervals? We'll just say a mixture may be needed depending on the points. Okay, if the points satisfy the question, we'll use a bracket. If the points do not satisfy the question, we will use a parenthesis. Okay, so it's a little bit more vague in this case. All right, last thing at the bottom, we're going to just go ahead and practice a little bit more domain and range because we're going to do more of that later today as well. So the question at hand for domain is, where do we have x values that have a closed circle? Okay, where can we or plug in an x value? So we'll start our graph on the left-hand side. Looks like our first closed circle happens at -5. Since it's a closed circle, we can include it. It's an x value that works. So we'll use a bracket. As we drag our pencil across, it looks like we don't have any open circles to really be concerned about. So we'll go all the way to the end at 7, and that has another closed circle, so we can use a bracket. For range, we got to check out the y values, so very similar but going low to high. We got to figure out where does our graph begin for the lowest value, and it looks like -4. That has a closed circle. It can be included, so we'll do a bracket. As we continue to drag up, we really don't have any open circles to be concerned with, so it looks like we'll just stop at the top, which has a y value of 4. All right, so again, notice how the question at hand is different. These did have brackets, whereas these ones had a little bit of both brackets and parentheses. Okay, it's all about the question that's being asked to you. How are we doing? All right? All right, we're going to go ahead and start the next section. So on page 51, we're going to take a look at another graphical characteristic. So we've been doing points, increasing and decreasing. We just did location, like above the x-axis, below the x-axis, on the x-axis. Let's check out some more. So in this section, we're going to take a look at comparing graphs. We did a little bit of this on Friday where we had the f and g, and we had to take a look at each one separately. We might see a little bit more of that in this section. So we're going to be dealing with two functions, f and g, and just like always, f of x, g of x, or g of x, h of x, whatever the function's called, it's normally representing a y variable. So let's think about what this function notation is asking us to identify. If we want the f of x equation to equal the g of x equation, what must be true? What should we be looking for on the graph? mathematically, we want the y value from the f of x to be the same y value from the g of x. What do you think that looks like on the graph? What do you think, Adam?
An intersection.
An intersection point. Okay, so f and g intersect. Okay. If they're equal, they're at the same location, meaning both graphs should have the same y value, just like the notation is signifying. So you're going to have two graphs in one spot, okay, creating that intersection point. Point is at one spot. What if we want the f of x graph to be greater than the g of x graph? Can you describe what that might look like graphically? If you think about the notation, we want the y value from f of x to be greater than the y value from the g of x. We need some help? Maybe, okay? So if f of x and g of x are exactly the same, that's where they intersect. This is telling us they're not the same, meaning one's bigger or smaller than the other. So intersection happens at one point. If they're different, they must be separated somehow, right? Intersection means they cross. If they don't cross, they're separate. So what do you think f of x is greater than g of x is telling us? If they're separate, they must be at different locations. Which function is this one and which one's this one? Yeah.
F of x would be above.
F of x is above g of x. Okay, that's what this symbol means. Greater, above, more than. Okay, so if they're equal, they cross, but if they're not equal, they're separate. So if they're separate, one function has to be above or bigger than the other one. So this notation is asking us, where is f of x above the g of x graph? The next one's kind of a similar concept. Notice how one is greater or smaller than the other, meaning they're separate. So this notation is asking us, where is f of x below g of x? Because it's smaller, it's less than. Okay, now the moment we start to compare functions where we have two graphs to look at, we kind of have to be careful, because if you take a look at the graphs provided, let's see, it says f of x is the dashed line and g of x is solid. Notice how this dashed line has a different domain than the solid one, because it looks like the solid one starts at -5, whereas the dashed one starts at -4. If you're going to compare functions, you can only compare them where their domains kind of intersect each other, where the domains or where their domains overlap. Okay, where both graphs basically show up in the same spot. Because if you're going to compare something, you need something else to compare it to. If you're comparing it to nothing, you can't really make that distinction. So if you take a look at this, take a look at the graph, we got to figure out what's the domain where both graphs kind of show up. Okay, so if the solid graph only shows up at -5, we cannot compare the f of x and g graph together because we only have the g graph available to us at that x location. So we have to make sure, where do both graphs actually show up? And it looks like they both would show up at -4 and then go all the way through to 7. Now we cannot include -4 because it has that open circle at the top. So when we start to compare graphs, okay, we have to make sure both of them are available at that x location, okay, where they show up simultaneously, meaning at the same spot. So let's take a look at some of these characteristics, okay, where they're equal, where they're above, where they're below. Let's check it out. So the first one is where are they equal, meaning where do they cross, where do they share the same y value. I think Adam told us that it was going to be where they intersect. So we can go ahead and highlight or show those spots. So it looks like x values of -2 and 5. The next one we want is where f of x is above the g of x graph. So f of x was the dashed line. We want to go ahead and highlight where is the dashed line above the solid line. So it looks like in this little section, and then in this one. Okay. Again, you can kind of ask yourself, as you drag your pencil across, you can see which one is above and which one's below. So as we start to drag, notice how dashed is above, and then it somehow changes to solid is above, and then when we get to 5, it looks like the dashed is above. So dragging that pencil might not be a bad idea. So the first little section here starts at -4 and goes to -2. And we got to ask ourselves, do the points satisfy the question at hand? Okay, is this beginning spot of -4 above the solid graph? Yes. Okay, so that does satisfy the question. But do we have a physical point there that is above the solid graph? No. Okay, so it is a yes, but since it's not a closed circle, it has kind of no choice but to be a parenthesis. Okay, the only way you're going to have a bracket is if you have a closed circle there and it satisfies the question at hand. Okay, so open circle basically has no chance whatsoever to be a bracket. We kind of have to be on the lookout for those. As we drag our pencil across, we get to -2, and we got to ask ourselves, at that spot, is the dashed graph above the solid one? Is the y value from the f of x greater than the y value from the g of x? Pietro, you're shaking your head no. Why?
Because it's on the intersection.
That's the intersection point, right? That's where we said the y values were equal, where they're exactly the same. So the y values could not possibly be different if they're equal to each other. So we cannot include that point. We still have more graph to cover, so we'll throw in the u. The next section looks like it starts at 5 and goes to 7. And we'll ask ourselves, does 5 answer the question at hand? Is the y value from the dotted graph greater than the y value from the solid? No, because that was another intersection point. That's where the y values are the same. Take a look at 7. We have a closed circle, so it has the possibility of being a bracket. We just have to see, does it answer the question at hand? Does the y value from the dotted graph, is that bigger than the y value from the solid? Yeah, so that can be a bracket. It's closed and it answers the question. Let's go ahead and try the next one. So we want the dotted graph to be below the solid one. Maybe dragging your pencil will help. We can see that the dotted is below the solid in that section. So let's see, we start at -2. Ask ourselves, is the dotted below the solid at that spot? I'm seeing some head nods, which is good. Okay, it's not below because they're exactly the same. That was an intersection point. As we continue to drag, it looks like the dotted is always below the solid, and we end at 5. That was another intersection point, so we cannot include that because they're exactly the same. All right, so take a look at these. Notice how, depending on the points again, we can have a mixture of brackets and parentheses. So again, it's not as clear-cut as that increasing and decreasing was, where those are always parentheses. So again, we'll say a mixture is needed depending on the points. We may need a bracket, we may need a parenthesis. It's all about, do we have a closed circle there or not? Does it answer the question or not? All right. I want you guys to try the next one. The domain and range. They're going to ask you about both graphs. So again, f of x is dotted and g of x is solid. Drag your pencil. Try to find domain and range for both. All right, any takers for the domain of f? That was our dotted one. If we drag it left to right, what do we think? Jordan, you want to give a shot?
-4 and 7.
Okay. So -4 and 7. So dotted looks like it starts at -4, no open circles to be concerned about, ends at 7. Okay, and then brackets and parentheses, what'd you do?
I have parentheses for the first one and bracket for the second.
So how'd you know the difference? That's good.
Because -4 is an open circle,
Okay.
and then -7 is a closed circle.
Okay.
7 is a closed circle.
There we go. -4, open circle. You cannot include it. There's not a physical point there. So we have that parenthesis. 7, though, has a closed circle, so it gets the bracket. Really good. What about the range? Low to high? Jordan, you want to keep going?
Yeah, -2 and 6.
-2 to 6, brackets, parentheses, what happened?
I have brackets for both.
Brackets for both. Good. Okay, so it starts at -2, physical closed circle at that spot, so we can include it. As we drag up, we do encounter an open circle at 5, but notice how there's another spot on the dotted graph that has a closed circle. As long as you have a closed circle, you're going to keep moving. Okay, that y value can be included at some point. So it looks like it ends at 6 with that closed circle. I like it. Those open circles can get tricky. We got to keep an eye out for them, but if there's another point, we're going to just keep dragging. What about g of x, the solid one? Any takers? Pietro, go ahead.
-5
-5 to
and 7.
7, brackets, parentheses, what happened?
Both have brackets.
Both brackets. All right, so closed circle at -5, closed circle at 7, no open circles in between to be concerned about. I like it. Do you want to go ahead and do the range?
-4 and +4.
Brackets, parentheses, what happened?
Brackets.
Brackets for both. Good. All right, so -4, closed circle, we can include it. As we drag up, there are no open circles to be concerned about, so it looks like we get to 4 with the closed circles. How do we do? Good? Awesome. All right, so let's kind of bring all this together, and we're going to take a look at a bigger graph and see what other characteristics we can identify. So we have another comparison. F of x is the dashed, g of x is the solid. For each quantity, write in words what they are asking you to find. Okay, it could be a very simple statement, nothing too extravagant. And then we're going to go ahead and identify either the values or the intervals that would answer that question. So, Find the values for x such that f of x equals 0. What is that notation asking us to find? Where should we be looking on the graph? This is what it means, write it in words. We're going to physically use English in a math class. Yeah.
X-axis.
X-axis points, okay, or x-intercepts, anything like that. So on the f graph, we're going to go ahead and figure out where it is on the x-axis. So f was the dashed. Looks like we get the x value of 1. Are there any other ones? What do you think, Sebastian? How did you get 15? The slope. Okay, notice how the dash graph does have an arrow, which means it would continue even though our graph stops at, what is that, 13? Okay, so it would continue. We have to find another one. So it looks like Sebastian used the slope. The slope looks like a half, up 1 over 2. So if we go up 1, we're now on the x-axis, but we still have to go over 2 more spots. So if it ends at 13 and we have to go over 2 more, looks like it'd be 15. Looks good. Can we write the equation of that line just in case we have to use it again? We said the slope was 1/2. Can we use the slope perhaps again to figure out where the y-intercept would be? Looks like it'd be negative. What do you think, Adam?
Negative 7.5.
7.5, it looks like. If you use the slope, work backwards. I think that's actually the same equation we had on the other one, wasn't it? Last week. All right. Good to have just in case we need it in the future. Let's try the next one. G of x equals 0. Okay, same notation, but now it's just asking us about the G graph. So maybe we'll be a little bit more specific. For the first one, we need the f graph to be on the x-axis. And then for this one, we need G of x on the x-axis. So G of x was the solid one. We'll roughly guess where these are. So maybe negative 4.5, 6, and 10.5. All right, what about the next notation? In words. Yeah?
Where the 2 graphs intersect.
Intersection points. Okay, so where the 2 graphs intersect. Intersection points. You could say equal y values, because after all, f of x, g of x, whatever is representing a y value. Okay, different words, different phrases you can use. So intersection points where they cross each other, somewhere right there, and another one there. So rough guesstimates. I don't know, this one looks, what do you want to say? It's not quite a half. You want to do negative 1/4? And then this one looks like the x value of 9. All right, we'll do one more. F of x is less than g of x. What should we be looking for on the graph? What does that notation mean? What do you think, Cole?
Where the line f of x is below g of x.
There we go. So f of x is below g of x. So we need the dotted graph to be below the solid one. Now, if you notice, the solid one ends at the x value of 11. So if we're going to be comparing these two functions together, we cannot go past 11. Even though the dotted graph does go past 11, we cannot, because the solid one stops there. Okay, you wouldn't have anything else to compare it to. So we're going to go ahead and check out that interval. So it looks like we start at that intersection point, which we said was negative 1/4. Is the dotted graph below the solid one at that spot? I'm seeing head nods. That's good. They're equal at that spot. They're not below or above. So we cannot include that point. As we drag across, the dotted one is clearly below the solid one until we kind of get to 9. That's another kind of interesting point. So right here, it looks like the dotted and the solid are equal. They're intersecting each other. So we cannot include that point. But we do have more graph to go. We're going to pick up at 9 again, because that's where we left our pencil. And as we continue to drag, we said we cannot go past 11, because that's where the solid graph ends. So at this point, at 11, notice how the dotted is below the solid. That answers the question. So we would need a bracket. We doing okay? Good. All right, we'll pick up there tomorrow. Just getting used to characteristics. What are we looking for on a graph? We'll do more this week. Bless you.